Welcome to the walkthrough for Part A of Assignment 2. The objective of this part of the assignment is to learn how to use the Java Executor Service framework. There are several videos describing the Java Executor Service that appear on my YouTube website. I recommend you watch these videos to ensure you understand the Java Executor Service. Of course, we'll also cover these topics in class as well, but take a look at these videos now to get a head start. In this part of the assignment, you use an instance of the Java Executor Service class that's created as a fixed-size pool of threads to enhance the multi-threaded implementation of the Palletary Simulator app that you implemented earlier in Assignment 1A. In Assignment 2A, you'll focus on creating a pool of threads that allow beings to concurrently gaze into a fixed number of Palletary. Hopefully you understand what a Palletary is by this point. The Palletary Simulator app is packaged as a project in Android Studio version 3.x. The app's written in both Kotlin and Java and demonstrates many Android capabilities. For the purpose of Assignment 2A, however, you only need to be aware of several directories. You'll need to be aware of the Beings Executor Service directory, which contains the skeletons you'll need to fill in, as described shortly. There's also a set of JUnit tests that exercise many of the Palletary Simulator features, and you should definitely make sure you use them to test the functionality you implement for this assignment. There's also a pair of instrumentation tests that stress test your app automatically. As always, to compile this code, you'll need to open the provided Android Studio project. Once it's open, you can run the project by clicking the green Run App button in the Android Studio IDE, which will prompt you to select an Android emulator to run. You'll need to modify several files that contain Java skeleton code by completing the to-do you fill in here tasks to provide a working solution. Please don't change the overall structure of the skeleton, just fill in the to-do tasks. The main places you'll be focusing are the to-do tasks in the Executor Service folder. In particular, you'll implement the Executive Service Manager.java class, completing the to-do tasks in various methods to implement a being manager via a fixed-size thread pool using the Java Executor Service framework. You'll also need to complete several methods in the being_callable.java class. That class is very simple to implement and is quite similar to what you had implemented previously. You'll also need to integrate your solution for the spinlock hash map folder from your Assignment 1B solution into the latest, greatest spinlock hash map skeleton, and use this as the implementation of the Palletary Manager for Assignment 2A. Most of the code is identical. There are a few extra accessor methods that you'll need to implement, which we used in our unit test to make sure everything's working properly. If all goes well, your simulation should be able to restrict the number of beings that gaze to the number of Palletary that are configured in the tests. As again, you've seen before, if there are 4 Palletary, then only 4 beings should ever be gazing on the screen at a time. And the unit tests and instrumentation tests should check that to make sure it's working properly. If all goes well, then when the test stops running, the app title bar labels will appear green. Conversely, if things go wrong or an exception is thrown or you don't implement something properly, then the title bar labels will be red when the simulation completes. Grad students have some additional work to do as always. Grad students need to be able to enhance the implementation of the Executor Service Manager to use Java 8 streams and various Java 8 features such as method references and/or Lambda expressions. Undergrads are welcome to implement these features, but you're not required to. As always, you can grab the source code for this assignment from my GitHub account and then take a look and fill in the to-do statements. This assignment is designed to give you a deeper knowledge of how to write Java concurrent programs using a thread pool, which will complement and extend the core Java multi-threading mechanisms we covered in Assignment 1A. We still haven't really gotten to any of the Android concurrency or communication frameworks, but we'll be covering these in upcoming assignments. Now that we've walked through the specification of the assignment, let's take a look at the skeleton code, starting with the Executor Service folder. As you can see, there's a class here called being_callable, which extends being and implements callable with an instantiation of the type of the callable being a being callable. That's kind of a curious recursive implementation. As you can see here, some of the methods are provided for you. You'll have to implement the being callable method. As you can see, you need to simply replace the to-do, implement the to-do by replacing null with the appropriate return value. That's pretty straightforward. And then here's the acquire, palantir, and gaze method. You can essentially cut and paste this from your previous implementation because it's essentially the same thing. Let's go take a look at a more interesting class. This is the Executor Service Manager class. And this is essentially a being manager implementation that uses the Java Executor Service, which will create a pool of Java threads in order to run the being simulations. This is a being manager instantiated with a being callable. We just looked at that. You'll have to go ahead and make a list of futures to being callables that are going to be running concurrently in the Executor Services thread pool. You'll have to make an instance of the Executor Service, which will contain the fixed pool of threads. There's a default constructor. You can ignore that. You have to fill in a couple of getter methods. These are used by the unit tests, so you have to fill them in. And basically, you can use these below. Instead of accessing those fields directly, you can access them by calling the getter methods. So one, of course, will return the future list. One will return the executor. Down here is the being callable new being method that returns a being callable. It's a factory method, so you can fill in the code, replacing null with the appropriate implementation. Run simulation requires you to call a couple of methods that are explained here. These methods are then implemented down below. One method is called begin being thread pool. And what this will do is create an executor service instance that will create a fixed sized pool of threads, where there'll be one thread for each being. So that gives you a hint as to how big it needs to be. You'll then call the getBeings factory method to iterate through the being callables, submit each of these being callables to the executor service instance, and then take the future that comes back to the list of being callable futures and add it there. The grad students have to do the same semantics, but they have to do it using a Java 8 stream. Undergrads are welcome to use the stream, but it's not required. The other method that needs to be implemented is called await completion of futures. And this will essentially spawn a thread that will wait for all the futures to complete. And inside that thread, there'll be a for each loop that will be used to wait for all the futures to complete. And if things work well, then you should tell the controller log to indicate that things worked. If an exception is thrown, then you have to catch the exception and tell the controller log which exception was caught. The grad students need to use a Java 8 stream instead of a for each loop. Once again, undergrads are welcome to use it, but they don't have to. Here's the shutdown now method. This method will essentially go in and cancel all the outstanding being callables via their futures, and then shut the executor down now. And then finally, it goes ahead and logs things to the controller logger. You can see here that controller.log is the method that you should be calling up in await completion of futures in order to indicate what has happened. So those are the main methods you have to implement. Then, of course, the other thing you'll need to do is you'll need to come over here into the spinlock hash map folder, and you'll have to cut and paste your implementation from before for the various methods that are required to make the spinlock hash map manager and a spinlock or a reentrant spinlock. Most of this code is very similar to before. The only things that are really different is that there are a couple of new methods, a couple of new getter methods, get spinlock and get available palantiri, and you'll need to implement these to return the appropriate field that's defined up here. And this is again used by the unit tests. So that just helps to consolidate things, put them in one place, give them a clear, identifiable name. So that's basically what you have to implement as far as the code goes. Not really a very hard assignment, but it'll teach you how to use the various pieces necessary in order to be able to make thread pools. And then in assignment 2B, we'll come along and we'll replace the spinlock hash map manager with a more interesting implementation that uses reentrant locks as well as some other mechanisms in order to be able to coordinate access to implement a so-called simple semaphore. But that will come in assignment 2B. Once you've filled in the skeletons, you can go ahead and run the various unit tests and instrumentation tests. Let me show you what happens when you run the unit tests. You come in here and you run tests in simulation. It should go ahead and build the tests, and then it'll start to run them. There's quite a large number of tests that will be run automatically. These tests test all kinds of different things. They test spin lock from your previous implementation. They test the executor service manager implementation. Later, as you'll see, that they'll also go and test some of the implementation artifacts from assignment 2B. Don't have to worry about those for the current assignment you're working on for 2A, but in 2B, there'll be many more tests. And these tests are very powerful. They use something called Makito, and we'll talk about how the tests work at some point later in the class, but make sure you get in the habit of running the test cases because they will catch many, many problems that exist with your code. In addition to running the JUnit tests, you should also get in the habit of running the instrumentation tests. Let's go ahead and launch the tests. This prompts us for the emulator we want to run. You'll see we already have one up and running. That goes ahead and launches the app, and then it starts to run a variety of stress tests. And you'll see in a second that these stress tests use 10 beings and 6 Palantiri with 10 iterations for each of the beings every time they get a chance to run. And as you can see, it keeps track of the number of completed iterations, also keeps track of the performance. We turn this test into performance mode. You can see it succeeded. It all turned green. The title bar all says green at the end. Then it goes ahead and launches another round of tests and provides some more stress testing, which does various starting and stopping just to make sure that the starting and stopping behavior works properly. So you can see that the tests are running very fast at this point. And if you have bugs in your code or race conditions in your code, then hopefully these tests will illustrate what the problems are. As you can see, the tests ran to completion successfully. And so that's a good indication that this implementation is probably doing the right thing.